So we have finished to understand about the inheritance. So in this inheritance, we are uh, creating two classes, student and the graduate student. So the class graduate student inherit from the student class because we call the student as the parameter in the class. So we can see another example. So this is an extended example, and if you have the book of the data structure, you can see this one. This example is about the numeric progression. The numeric progression is a sequence of numbers, and each number depends on one or more of the previous numbers. So in this case, there are three kinds of progression. First is the arithmetic progression. Second is geometric progression. And the last one is Fibonacci progression. In the arithmetic progression, it means we want to find the next number by adding a fixed constant to the previous value. So if I have a number 1 and then I want to add by 1, then the next number will be 2. I want to add by 1, then the next number will be 3. So I want to add by 1, then the next number will be 4, and so on. If I start from 1 and I want to add by 3, then the next number will be 4, and the next number will be 7, the next number will be 10, the next number will be 13, and so on. So this is the arithmetic progression. The next number by adding a fixed constant. So it determines the constant. If the constant is 1, then it will be 1. If it is 3, then it will be added every 3. The geometric progression means we want to know the next number by multiplying the previous value by a fixed constant. So multiply. Okay. This one is just adding. Then if I want to multiply with 2, so the first value is 1, then the next value will be 2, and then the next value will be 4, the next value will be 8, the next value will be 16, 32, and so on. So the value of 8, it is 4 multiplied by 2. The value 16 is 8 multiplied by 2, and so on. What about Fibonacci? It is a number that follows the last two numbers. So ni plus 1 equals to ni plus ni minus 1. So if I have 1 and then I have 1, then this number will be 1 plus 1. If I have 3, then this number will be from 1 plus 2. If I have 5, then this number will be from 2 plus 3. If I have 8, this is number from 3 plus 5. Okay. We can make the class diagram like this one. So I have the progression class, and I can create the arithmetic progression, geometric progression, and Fibonacci progression. So this is the class. We have the class progression. This is a constructor. And if you don't define any value, then the starting value will be 0. So the current equals to start. Advanced means we want to know what will be the next number. Next, so it will go to the next number with sum of the formula. If the current is known, then stop the iteration. And if it is not known, then the answer is the current. We will go to advance. It means we will add by 1 and then return the answer. Iteration. So you know already about the iteration. We will go to the next and we can print the progression. So the print will use this command. Okay. So if you already learned the Python command in one line, okay, so it is the command in one line. We are going to do the join. str means we want to convert the data type from numbers to string. And then next, it means we want to do the next iteration from the self, from that particular number for the range until n, and we are going to check for every change. So this is the class progression. It means this is the superclass or this is the base class. For the base class, it should include everything that the child class or the subclass can do. Now let's look at the arithmetic progression. The arithmetic progression, it will inherit from the class progression. And then let's see. We have the starting point as 0 by the default, and the increment will start from 1 by the default. Super. So we can just call the progression class and give the parameter start. If there is no value on the start, then it means 0. And then the increment, it will be from this parameter. Advance. So we can go to the next value and it depends on the increment value. So as I mentioned to you, if we set by 1 for the arithmetic progression, it means we will do 1 and then we will add 1 with 1, it means 2. We will add 2 with 1, it means 3. Okay, we will add 3 with 1, then it means 4, and so on. So this increment will determine the next value. In the geometric progression, it has the constructor with 2 parameters, but the variable is different. Now we are using base. As you might know, whenever we do the multiplication, if you multiply with 1, so it will be always 1. If you start the value, you cannot start with 0, because every value multiplied by 0 will be 0. Then I will start with 1. So we also call the superclass. The superclass means the progression class. And then for the base, we are going to use the default value, which is 2. So this default, you can change with the parameter. If you do not give any value, then it will be 2. For the advance, now I determine the advance. the current will be the multiplier of the base. We call this is the off-right. Okay. We call this is also the off-right because we already have this advance in the progression. This one. So in the progression, we already have advance. It means I want to go to the next value. But the next value will be depending on the progression type. If the progression type is arithmetic, then it will be addition. If the progression is geometric, it will be multiplication. Then we can update this method in every of these subclass. For the Fibonacci, again, we define the constructor. In this case, we define the first and we define the second. And then we call the super. So the super is the super class. And then we want to get the previous. So we call this previous is the fictitious value. So if you already have the number, let's say I have number 0 and 1. Okay. So maybe this is the first, this is the second. So if I want to know the next one, so if it is the first, it is the second. So after I know this one, then I will have, this is the second, this is the first, and it becomes the previous value. Okay. So by using this formula, I can know the second minus the first. And for doing the advance, for looking at the next value, we can use like this formula. So the previous will be the current. So if I have the next value, then the previous will be the current. So this will be the previous. And then the current will be the previous plus the current. So the current, it means here, it will be the previous plus, this is the previous plus the current. So plus this one. So this will be the next current. Okay, so let's see the progression. So I already gave you the code. This is the code from the author. We have the progression, we have the constructor, we have the advance, and then we have the next. If it is known, then we will stop. If it is not known, then it will always go to the next. And then we are going to print for every possible numbers. So this is the arithmetic progression, this is the geometric progression, and this is the Fibonacci progression. Okay. Now we have the main function. You still remember what is main function? We want to execute the code, or that is the code to call every of the class. So first, let's see. Print default progression. So we are going to call the progression class. Okay, this is the progression class, and print progression 10. What does it mean? if you look at the print progression, so we have n, it will be 10. So I will do the looping until range 10. Okay. And then the remaining is just to show the result. And this one means I'm going to give a space for every printed number. The second one, maybe let's try to run. Which one is ch03 progression.py. Okay, because in my case the code is in the folder ch03, so I call the folder name ch03 and I call the file name progressions.py. So the default progression, it shows 0, 1, 2, 3, 4, 5, 6, 7, 9. Because I use the print progression 10. Okay. Now, if I want to call the arithmetic progression with the increment 5. So if I have the increment 5, then the number will be, if the starting number is 0, so the next number will be 5. Next number will be 10. The next number will be 15 because the increment is 5. So the arithmetic progression with increment 5 is 0, 5, 10, 15, 20, 25, and so on. And we call this with the arithmetic progression class. And as you can see, we put the parameter 5. This parameter 5 means when we call this class, we have two parameters. We have parameter increment 1 and we have parameter start 0. But here we have only one parameter. So what does it mean? One more time. We have one parameter in this class. And when we call this class, we have only one parameter. But actually in the constructor, we have two parameters. Is it okay? Yes. Okay. Because when we have only one parameter, it will follow the sequence. Okay. So because we have only one, then this will be the first parameter of the arithmetic progression. What is the first parameter? The first parameter is increment. Then we will not use 1. Instead, we will use 5 as we define in the class. What about the start? Is it okay not giving any definition of the start? Yes. If you don't give any parameter, if you don't give any value, then it will start with the default value, which is 0. That's why you can see the result is starting from 0. This is the default value. Now you can see the second example. In the second example, we have two parameters. The arithmetic progression, we have 5, 2. It means the increment will be every 5 and the starting number will be 2. So the starting number is 2 and the increment will be every 5. 2, 7, 12, 17, 22, 27 and so on. Next, the geometric. So in the geometric, we also have the same case, but we don't have anything inside of this parameter. Is it okay? Okay. Nothing inside this parameter. Is it okay? Yes, it is okay. Yeah. Because if we don't have any value, then Python will consider this is the default value for the base and this is the default value for the start. Then when you do the geometric progression, if I want to print for 10 elements, then you will see like this one. 1, 2, 4, 8, 16 and so on, because the base is 2 and the starting number is from 1. So you know the geometric progression is multiplication by 2. So 1 multiplied by 2 is 2. The next number is to multiply by 2 is 4. The next number is multiplied by 2 is 8 and so on. Now I want to change the base geometric progression with base 3. It means I'm going to use 3 as the base and please show for the 10 elements. Then in this case, we will multiply with 3. So 1 multiplied by 3 is 3. 3 multiplied by 3 is 9. 9 multiplied by 3, 27. 27 multiplied by 3, 81. Fibonacci. So the Fibonacci is also the same case. If you have no parameter here, then the starting number will be 0 and 1. Why 0 and 1? Because we already defined in this class. So if we start with 0 and 1, then the value will be like this one. So 0, 1, 1, 1, 2, 3, 4, 5, 8, and so on. This is the common Fibonacci. But you know that the Fibonacci will have the formula for every number. It will be the addition of the previous number and the last 2 numbers. So with those formula, we can specify another possible starting value. So in this case, I'm considering to use 4 and 6. So the first will be 4 and the second will be 6. Then you will see this result. 4 is the first, 6 is the second, and then it goes to the next. So 10 is the result of 4 plus 6. 16 is the result of 6 plus 10. 26 is the result of 10 plus 16, and so on. Okay. Now my question is it possible if I want to change this? Six and then 4. By looking at this code, is it possible if I change 6 and then 4? Let's see. Okay. Everything is okay. Oh. Okay, let me give this title. Start value is 6 and 8. Yes, possible. The result is also the same. Sorry, not the same. So if you check the sequence in different way, then it will show different because it depends on the sequence. So the first is 6 and the second is 4. So the next will be 10 is the same, but the remaining will be different because the sequence is different. Okay. So it is not the same with the other kind of geometry which follow the sequence rule. But this sequence will follow the 2 last digit. Okay. So that's all about the object oriented. So we will learn more about the algorithm analysis. So let's check this algorithm analysis section. So in this section, you will learn about the pseudocode and then some important functions, and then you will learn about the pick O notation and the variance. Running time analysis. In the algorithm, the running time is very important performance measure. So most algorithms transform the input objects into output objects. And the running time of an algorithm typically grows with the input size. Average case time is often difficult to determine. So we focus on the worst case running time. The worst case means the running time when it is the highest load. The best case means the running time when it is the lightest load. The average case, so you can do something like 10 times experiment, and after you do 10 times experiment, you make the average. So the running time information you can check based on the best case or the average case or the worst case. Let's say this is the input size, and then when you do the experiment with the input size of 1000, the best case runs in like 15, yeah, maybe 10 seconds. So the average case, it runs 20 seconds, but the worst case runs in the 30 seconds. So whenever we do the time performance, usually we will look at the worst case, because the best case is, yeah, it cannot give any good result, or you can have some misleading information. The worst case running time, it is easier to analyze. And then it is crucial to applications like HIMS. So let's say you want to play games, and then if the game is very slow, then you do not want to play the game. Finance. Okay, so if you buy and sell stocks, you want to get the result as soon as possible. Robotics. So if you are dealing with the robotics research, so you want to look at the robots to do fast thing. Okay? So if the robot can do fast, then it is good. If the robot is very slow, then you do not want to have that robot. So we call this is the analysis of the running time with the worst case. So what is the worst case scenario? What is the worst case performance time? And when we check the running time, we can check based on these two important things. The first, you can look at your experiments. So you can make your code. And after you make your code, you can run in Python, you can run in Jupyter Lab, and you can check how long does it take to finish the algorithm. However, we can also use another analysis. We call it theoretical analysis. So for the experimental studies, we can write a program and implement the algorithm. And we can run the program with inputs of varying size and composition. So we want to note the time needed to run that algorithm. So for example, I have this algorithm, okay. So I can check the starting time and I can check the ending time. So I will look at some performance. So if the input is 50, what is the time? If the input is 100, so what is the time? So let's say, let me make a new code. So I can import the time, and then I can call the start time, and then I can do something here, and I can check the end time, and then I can look at the elapsed time. It means how many times we need to get the result when we start the algorithm. Okay, let's say, okay, I have the end time minus start time. Okay. So let's see if I want to make let's say I want to make something related to the multiplication. Okay, just give a very simple multiplication, or okay, maybe for I in range n. Okay, I want to multiply I with n. So let's say this is I have a variable result equals to 0, and then let's say base equals to 1. Okay, so the result will be base multiplied by n. Yeah, this is just example. Okay, so I want to do kind of multiplication with this function. So you know that I can call this function. Let's say if I multiply 5, okay, nothing happened because I do not do anything. Let's say if I want to print the result. So the result is 5. Okay, because 1 will not be changed. If you want to make something more interesting, base equals to base plus 1. Okay, then it will be 25. Okay. Now, I want to run this algorithm so I can check the time performance. I will put it in between this statement. So I can check the starting time and then I can check the elapsed time. So I can know the elapse. The result is 25 and the elapse is, okay, very small, 0.000 something. Let me change this number. I changed to 100. What happened? Okay, the time is still this one. What about if I change this to 10,000? Okay, now the time is a little bit, yeah, there is some time. Now I want to add this to 1 million. Okay, now it becomes 0.08. If I have 10 million, 100 million, then it becomes slower. Okay, you can see now it takes 8 seconds. So that's the meaning by doing the experiment. By doing the experiment, then you will do for every input size and then you will plot into this kind of graph. So if you have the input is 100, how many seconds? If you have the input 1 million, how many seconds? And so on. So this will be your team project. Okay. You will find your algorithm, you will make your own algorithm, and at the end, you need to show this kind of experiment. And yeah, of course, you need to compare which one is better, which one is worse. Okay, let me stop. Let's have a break. I'll continue after the break.